Ha! Well there. Hi. Welcome. Welcome to this video. My goodness. Glad you could be of an acquaintance to be watching this video. The first part will be edited out. Do this as the introduction. Hi there. This is your host, you know who. And I bid you welcome to this video. I hope that you will be enjoying this video. Shot late at night, 10:33 p.m. May 7th, 2016. That's right. 2016. Today, we'll be showing a very classic piece of what you could call retro technology. It's not a tape recorder, but it is a device capable of recording data. Activate. These here are very special items. You may recognize these amazing feats of technology. They are EPROMs. Erasable, programmable, read-only memory. What these are memory chips. Look how beautiful that thing is. The device that will be shown is a vintage EPROM programmer. But this EPROM is out of the picture because only these three EPROMs shown, as well as some other ones that are not shown, can be programmed by it. That is the 2716, which has 16 kilobits of data, otherwise better known to be 2 kilobytes of data. 2 kilobytes. Using my top secret state-of-the-art teleportation technology, I will teleport the EPROM into the socket of the vintage programmer from the 1980s. The deed has been done. The teleportation has been achieved. This right here is a vintage EPROM programmer. Excuse me for a second. There. It's timeless now. This is a vintage EPROM programmer from the 1980s, which had been built from a kit, I believe, during that time. Judging by the latest date codes, I believe 1983. Let's shut off the lights and see if you can see the displays. Okay, now you can actually see what the displays are showing. My camera decided to go black and white, but you can see right here 0BD is the address. The data at that address is FF in hexadecimal. Let's reset the address to the beginning. Now you can see we are at address 0. Data is F3. So what I can do with this EPROM programmer is I can program whatever data I want onto this chip, as long as it is 2 kilobytes or less. That is 2048 bytes. Here's the drawback, however, of this programmer. You can only program 1 byte at a time on this thing. You have thumb wheels right here. Let's turn the light back on. You have thumb wheels right here to select the binary, the hexadecimal data. They're the same thing, just different notation. Hexadecimal data you want to put in on the chip, and a button to program, and it will automatically go to the next address. Put the data you want, program. If you made a mistake which involved writing a 0 and you want to correct that mistake, take the EPROM out, stick it in a UV eraser, turn it on for 20 minutes, and start all over again. So say you've programmed some special data and every single byte was absolutely important and paramount, and this was the only programmer you had, and you're to the 2047th byte, and you make a mistake putting in that 2048th byte, which involves writing a 0, guess what? I'm sorry, you have to start all over. That's right. This programmer can only program 1 single byte at a time. Isn't that insane? It's a very manual device, but it definitely serves an educational purpose in basic EPROM programming. So right here, this is not the main on-off switch. This is the 26 volt line, which they probably should have made 25 volts instead. If you want to be programming an EPROM, go ahead and turn it on. This is the frequency adjustment. If you want to go into free run mode, it will just cycle through all the addresses on the EPROM, and you can adjust the rate at which the addresses are incremented. This, I believe, only applies to reading back data from the EPROM, and there's no ports on this device at all to hook it up to a computer. It is all done completely manually. If you want to read data, look at the display. If you want to transfer data, write it down or type it into a computer from what you see on the display. That's right. This is a completely manual EPROM programmer. This is this free run / single step switch I just showed earlier. This switch switches between read and program modes. Then there's a reset button to reset the address to 0. Then there's single step, so whenever you were looking at data, reading back data, you can step through the addresses, 1 address at a time, and program, which when you're in programming mode, it will step through the address and program the data that you have entered, but in read mode, it will not step through the address. This programmer is so primitive, it doesn't even have a 0 insertion for socket. It just has a regular chip socket. But it serves its purpose. Now, we will find a start of a space of blank data, that is, having FF or all ones in binary, on this EPROM, and we will program some ASCII data. We'll put it into free run mode and search the chip until we found a place that has a bunch of FFs. Because I already have some data programmed into this chip, as you can see. Okay, we got FFs going here. Let's go to address. Oh, never mind. There's some data, more data. I gotta keep searching through until I find a blank spot. And now I'm just manually stepping through the data. This was given to me from a man who works at the university I went to, and he said it was built from a kit. So chances are this was used for educational purposes, or maybe for labs back in the day where people had to program data onto an EPROM. When I was in school, none of our classes made us use EPROM chips. They were too outdated. We did use RAM, and we did, amazingly enough, use DOS and floppy disks. And there's more data on here than I was expecting. There's some FFs. I think we found a spot. Let's start at address 380 in hex. Let's make sure, actually. I'm not going to start at 380. Or actually I will. No, I won't. 390 in hex. We'll start at address 390 in hex, and we will program some data onto this chip. Okay. Now we're going to start programming in some data. We're going to set this to program mode. Now, whenever you're in read mode and you go into program mode from read mode, it does not actually put it into program mode until you cycle power on the unit, which is really annoying. Because notice I'm in program mode, but I cannot change the data that I want to put in with the thumb wheel switch. If I cycle power, now I can change the data I want to put in on the thumb wheel switch. So now I have to go into the address counting mode and find address 390 in hex again. And I don't want to go past it, otherwise I'll have to go back, or I could just start a little later. Getting there, getting there, getting there, getting there. Whoa. Okay, I'm gonna. Doesn't allow you to single step. Well, if I do a program with the power supply turned off, it won't do anything with the programming power supply. Okay, here we are. We're at address 390. Now I'm gonna put on my 26 volts. Actually, I'm gonna go ahead and put in my data first. I'm going to put in a 45 in hex. Now put on my 26 volt line, and I'll press the program button. We've entered that data onto the chip. Now we're going to enter another number. The next one will be 50. In hex, of course, so it's not actually 50. It just looks like 50. Okay, that byte has been programmed. We program 52 in hex. And that byte's been programmed. Now we'll program for F. For D. Five, 3. 20. 41. 52. 45. 20. 41. 4D. 41. 5A. 4-9. 4E. 4-7. 'Last but not least, 2-1. I'll put several of those 2-1s, followed by a few 2-0s. Turn off the 26-volt line. Go back to the read mode. Reset the address and go into free run. Now we're going to try to get back to address 390 to see if we can see the data that we have programmed onto the EPROM has been programmed successfully. .390 should have 4-5, 50, 5-2, 4F, and so on. You can see the data has successfully been programmed onto the EPROM. So you might think, okay, well, what's so great about that? You've seen me program the hex into this EPROM, read it back on the display from the EPROM. What's so great about that? Well, let us take this EPROM out and review the data on a modern EPROM or a more modern EPROM programmer and see what the data is like. Here's just a few more views of this EPROM programmer, what it's like, what it looks like. It's a classic, really. I love the shape of that case. It's just, I love it. Love this classicness of this thing. Piece of vintage technology history right here. Just look at that thing. Now let's hook this up to an EPROM programmer, a more modern one. Witness this EPROM programmer, and also for curious parties, an EPROM eraser. Let's take this EPROM and stick it in to the programmer. I do it like this, but then the light just kind of makes everything go crazy. Okay, maybe you can see the EPROM programmer a little bit better now. This light just hanging here. Got the EPROM right in there in the 0 insertion force socket. And tab facing up, EPROM flush with the bottom of the socket on this EPROM programmer. Advantech Lab Tool 48, also known as a Dataman 48, I believe. This one is XP upgraded. Right here is an EPROM eraser. You can put EPROMs on little foam. It's this tray here, and turn on a UV light, and it has a timer on it, so you can time it for 20 minutes. But that's not what we're going to be doing right now. We're going to be reading the data off of this EPROM using the software for the more modern EPROM programmer. I was able to recover the data off of the EPROM. And as you should be able to see in the still picture I put, showing on the software the area where the data is, it says, EPROMs are amazing. But some of you out there fluent with ASCII may have already realized that. I hope you enjoyed this video of an ancient, very primitive style, 1 byte at a time, completely manual with no I/O ports to go to any computer whatsoever, EPROM programmer from the 1980s.